Welcome back, grade 11s. This is our second video on static friction examples, and we will go through some more problem situations. So the first one is actually number 3. It says, the forwards of a school's rugby team are pushing a scrum machine. The normal force exerted on the scrum machine is 10,000 newtons. The machine isn't moving. With the coefficient of static friction being 0.78, calculate the following. Calculate the minimum force the forwards must exert to get the machine to start to move. So let us just draw the situation again. So here we have, there is a weight acting on the block. There is a normal force, and they say that the normal force is 10,000 newtons. The machine isn't moving, so you in a static friction situation, and mu s is 0.78. That's the ratio between the frictional force, maximum frictional force, and the normal force. So they want us to calculate the minimum force the forwards must exert. This minimum force, the minimum F applied, will be equal to the maximum static friction. And the maximum static friction we can calculate using the coefficient of static friction and the normal force. So it's 0.78 times the 10,000. 0.78 times 10,000 would give us 7,800 newtons. That would be required in order to get this thing to move. The next example, example number 4, says a block of wood experiences a normal force of 32 newtons on a flat but rough surface. A rope is tied to the block and a force of 8 newtons is applied parallel to the flat surface, causing the block to start sliding. Determine the coefficient of static friction. Draw the sketch to represent the situation. There is a normal force of 32 newtons. The rope is tied to the block and a force of 8 newtons is applied. Parallel to the flat surface, causing the block to start sliding. There is friction, and this friction would be opposing the motion, and it's just starting to move. So that would be the maximum static friction. Now, in this case, the maximum static friction will be equal to the F applied. So it is equal to 8 newtons because the block is just starting to move. The applied force at maximum static friction is equal. Now we have enough information to calculate mu s, the static coefficient of friction. It would be the ratio between the maximum static friction and the normal force. So it would be equal to 8 divided by 32. That gives us a quarter, 0.25. This has no unit. It is a constant of proportionality where we compare static friction and normal, which are both measured in newtons. I hope these examples help you in understanding the different situations. In our third video, we'll continue discussing more examples. Thank you for watching.